My goal in each of my YouTube math lessons is to add humor to mathematics besides showing a problem-solving method that always works. By having a method that always works, all the problems are bound to be easy, although of various lengths. Here I'm going to do one example problem to illustrate simplification of radicals. I start by looking at the index. If the index position were blank, I'd assume 2 as the index, but here it is 3. Therefore, I'm going to rewrite the radicand in a way that features triples of factors throughout, just as the x cubed already is. My decision of whether to feature doubles, triples, quadruples, or whatever depends on the index. To transform the 40, I do prime factorization by the going down the ladder method. We keep working with this animal through division by the smallest prime we can, until we catch it by its tail, the 1. Then we do our anatomical inventory. There are 3 organs called 2, and 1 organ called 5. This inventory we denote as 40 equals 2 cubed times 5. Succeeding in featuring another triple. For the y to the 5th power, we divide the 5 by 3 to learn how much we have in triples of y. We have quotient 1 and remainder 2, which is to say 1 triple and 2 left over. So y to the 5th power equals y cubed, y squared. For the z to the 7th power, we divide the 7 by 3 to learn how much we have in triples of z. We have quotient 2 and remainder 1, which is to say 2 triples and 1 left over. So z to the 7th power equals z squared to the 3rd power. Notice that the 2 comes before the 3, just as in my saying 2 triples. At this stage, we are ready to write the cube root of the radicand 40 times x cubed, y to the 5th power, z to the 7th power, equals the cube root of the radicand 2 cubed times 5 times x cubed, y squared, times the cube of z squared, times z, which is obviously a temporary setback from simplification. Here's where the fun begins. The last expression I wrote is a jail that currently is housing 7 constituencies of inmates. Those constituencies are 2 cubed, 5, x cubed, y squared, the cube of z squared, and z, each housed in a separate ward. The address of the jail is the index number of the radical. The warden is giving us a tour of this jail. He asks us whether we have any questions. You ask why the wards 2 cubed, x cubed, y cubed, and the cube of z squared had the jail's address on their gate. He explains that the inmates of those wards have the right to send a representative to court to plead to the judge to have their entire constituency released. The representatives are 2 x, y, and z squared, and they all succeed in their plea, resulting in the answer. The hapless souls who had on their gates a 1, a 2, and a 1 respectively languish in jail.